Hey, chemistry. Today I shall be going through the 12s, which are in Unit 7. So redox, Unit 7, 12s is what I'm going through. This is going to be a very short video. If you grab this sheet out, what you'll see is there's kind of like 5 problems on the front, another 4 problems on the back, and then some additional stuff at the bottom on the back side. It's not a long worksheet. It should go pretty quick. What we're doing and what we've done on the 5s and the 10s is we are building up your skills in redox to eventually balance the whole full-blown redox chemical reaction. So today is just kind of another incremental step in this video. And if you were absent, I hope you can watch this very quickly and pick up exactly what I'm doing. It's not too bad, I hope. All right, so let me get into my presentation. A couple introductory slides, just a couple of real-life examples of redox occurring in the world. So the first one here is bleach. So bleach, the way bleach works is bleach actually removes color by removing electrons. In other words, bleach is reduced, meaning that it's gaining electrons, and bleach causes pigments in like white clothing to be oxidized. So bleach is actually what we call an oxidizing agent. We haven't talked about agents just yet, or if we have, it was very briefly. So the substance that is doing the oxidation is called the oxidizing agent. But the oxidizing agent itself is actually reduced. It's a little weird, but I hope that makes sense. Another real-life example of redox are fireflies and electric eels. So electric eels and fireflies both undergo redox reactions to illuminate or electrify, in the case of the eel, themselves. So a couple examples. Maybe you find that interesting. Hopefully you do. On to the worksheet. I'm going to go through the first 2. I'll make a comment about number 3, and that's it. So I should be done in about probably 5 minutes. Here we go. Number 1, oxidation half reaction. So what we have here is called a half reaction. This will make more sense eventually once we start doing the full-blown thing. But this half reaction is all balanced for you with one exception. What we're missing here is the electrons. So because this is oxidation, remember OIL, oil, RIG, rig, oil rig, oxidation is when the electrons are being lost. Reduction is when those electrons are being gained. So in this instance, because it's oxidation, because we're telling you it's oxidation, the electrons are going to be lost. Let's go through what we have. The first question is what is the total overall charge on the reactant side? So if I'm looking at this example, mind me, just going to fall. If I'm looking at this example, I have my arrow right there, okay, and this is my reactant side. We're asking for the total charge on that side of the chemical reaction. So if I look, I have these chromium 3+ ions. How many of those chromium 3+ do I have? I've got 2 of them, right? So to do the math, I need to account for the fact that I have 2 of these. The grand total on the reactant side is 6+. That did not work. There we go, 6+. Okay. On the product side, my total charge, again, I have to look at what I have. I have this dichromate. You don't need to know the name, but it's a dichromate, and it's got a 2- charge. I just have 1 of those. But then I have 14 hydrogen ions. You have to account for those coefficients. The big numbers out front are telling you how many of that type you have. So yes, this is a 2-, yes, this is a 1+, but I have 14 of those 1+. So if I do the math there, I should have 14 positive minus the 2 from the dichromate for a grand total of 12 positive on that side of my chemical reaction. So where are we going with this? Well, here's the deal. The very last step, or one of the last steps of balancing a redox reaction, is adding the electrons. Remember, redox is all about electrons gained and electrons lost. So we need to acknowledge how many are being gained or lost in this process. So this is oxidation. We're going to lose some electrons, and by looking at the total charge over here, and by looking at the total charge over there, we can determine how many electrons we're actually losing. So because this is 12+ on the product side and 6+ on the reactant side, I need to add electrons to the more positive side so that they both have the same charge. So how do I bring 12 plus down to equal 6 plus? I add 6 electrons. Electrons are negative, right? So these 6 negative charges now make my total on the product side 6 plus, which matches the reactant side, and we're good. So how many electrons are we going to add? We're going to add 6. Which side do they go on? These go on the product side. Okay, there's 2 ways we can catch that. They go on the product side, number 1, because this is oxidation. We are losing electrons. Well, if electrons are being lost, they should be a product for our half reaction. How else could we figure it out? Well, we can figure it out just by looking at the numbers, right? I've got a 12 plus, I've got a 6 plus. I need to add the negative particles to the side that's more positive. Okay? And then last but not least, it says write them in the half reaction above. I got ahead of myself, I already did that. And that's it. So this sheet has 9 of these. That was the first one. The next 8 are going to be more of the same. I'll do one more for you. I'll make a comment on number 3. And then the rest of this is going to be your homework for following class. All right. There's the answers. We don't need that. I already did that. We're good. All right, number 2. So same kind of thinking. I have a half reaction. I've got a reactant side. I've got a product side. Let's do some math. What is the total overall charge on the reactant side? Well, I've got water. That's neutral, 0 charge. I've got H2S. That's neutral, 0 charge. So when I add those up, I get nothing. How exciting. My total charge is 0. On the product side, I have H2SO4 and I have H1+. H2SO4 is neutral. There's no charge next to it. But H1+ is 1 plus. How many of those do I have? I've got 8, right? You cannot forget about that coefficient. I've got 8 total positive charges on the product side. The next step says we've got to add electrons to make the more positive side come down so that it equals the other. So I've got a 0 charge. I've got an 8 plus charge. This is pretty easy. I need 8 electrons over here. There we go. So let me just fill in my blanks. How many electrons am I going to add? I'm going to add 8. Where should they go? I'm going to put them on the product side. Again, how could I have figured that out? Well, 2 ways. Number 1, it's oxidation. Oxidation means I'm losing electrons. If I'm losing electrons, they've got to go over on the product side. The other way I can figure this out, this side's 8 plus, that side's 0. When I add electrons, electrons are negative, so I have to add them to the side that is the more positive side. Write them in. I already did. We are good. All right, so one comment about number 3. Number 3 is reduction. Now, reduction is just the opposite of oxidation. So when you try this problem and go through the rest of the worksheet, if it's reduction, the only difference is going to be is that now your reactant side is going to have the more positive charge. So when you add your electrons, where are they going to go? They're going to be added to the reactant side in problem number 3. That's it. Easy peasy. If you need any help, please let us know. We are in the open lab every now and then. You can find that schedule on Canvas, and I hope you have a great day.